table shows the results of two random samples that measure the average number of minutes per charge for lithium ion batteries, right, versus nickel metal hydride rechargeable batteries. So in each case, we're given the sample mean, the sample standard deviation, and the sample size. So conducting a hypothesis test, we're going to be using t-statistics. So here it says perform a hypothesis test using significance level alpha 0.01 to determine if the average number of minutes per charge differs between these two battery types. Assume population variances, right, are not equal. So here for our hypotheses, we're trying to figure out if there's a difference. We're not trying to figure out if one is greater than the other necessarily. So here, the null hypothesis would be equal to, and our alternative hypothesis will be not equal to. So, continuing on to find the test statistic. So to run our hypothesis test in StatCrunch, I'll choose Stat, t-statistics, and this is a two-sample test. And here I have the summary data. And so here I will enter in the summary statistics. So for lithium, the mean was 96.7. The sample standard deviation was 6.9. The sample size, 14. And for nickel metal hydride, we have a mean of 82.6, a sample standard deviation, 11.7, and our sample size here, 18. So in this case, we are to assume that the population variances are not equal. So we will not use pooled variances. We will not check that box. Here are hypotheses. The difference is equal to 0 and not equal, already done. So here if we press compute, here we'll have our results, and here we have our test statistic. So our test statistic, our t-value here is 4.25. So we'll enter in 4.25. So next, to find the critical value, our rejection region. So in StatCrunch, in order to do this, I will use the T calculator. So we'll choose Stat Calculators, and we'll use the T distribution. All right, here, well, maybe I should go back. If I notice, the degrees of freedom here is 28.223. All right, whenever we do not use a pooled variance, the degrees of freedom has a really messy formula, but I'm going to just use 28 as my degrees of freedom in this case. So, going back to our calculator, we use degrees of freedom, 28. And here, we're going to be doing things between. And the reason I say between is we're doing a not equal to a two-tailed test. So the two tails are going to add up to be 0.01. So the area in the region in the middle should be 0.99. So I'm going to change the area here on the right. The area of the red shaded region should be 0.99, leaving 0.01 as the total in the tails. So here, critical value or values. So in this case, I've got two critical values. I've got the negative 2.76 and positive 2.76. So as a result, our test statistic falls outside that range. So because our test statistic is greater than the critical value, does not fall within the critical values, I guess might be a better choice here. since there's two of them, and then we'll say we're going to reject. So in essence, it either falls into here or into here, and it was well outside over here to the right. So we'll reject the null hypothesis. Okay, using the p-value method, so let's return back to our initial test. The p-value, they said it was 0.0002, so rounded to 3 decimal places. I'm afraid that that's just 0 off the charts. And since the p-value is less than the significance level, 0.01, we will reject the null hypothesis. So same result. And so what assumptions need to be made in order to perform this procedure? Well, we need to make sure that they were independent random samples, but we also need to make sure that the sample means are normal, and since the samples are not large enough for the central limit theorem, we need to assume that the populations from which we sampled, the measurements were normal. It must be assumed that the distribution for both populations are normally distributed and the samples are independent. So letter C. And there we go.